Hello everyone. Today let's solve the problem merge two sorted list. So you can just go through the question and you can go through the example as well to understand the question pretty well. So I'll just summarize the question so that it will be easier to understand. So we are given two heads of the sorted linked list. You can clearly see here we have been given the two sorted linked lists. I mean two heads of the sorted linked list, list 1 and list 2. You can clearly see here, right? And our task is to merge these lists into the single sorted linked list. You can clearly see here we have to um, merge these two lists into the one sorted linked list. So the merging should be done by splicing the nodes together. This is very simple. This is very important. The merging should be done by splicing the nodes together, and the result should also be sorted. So we have to get the result in the sorted order, right? So here you can clearly see 1 2 4 and 1 3 4 they have given here. 1 1 this one 1 2 3 4 and 4. So this is of the ascending order, right? So they have clearly asked the result should be should also be sorted, sorry. And what we'll do first, let's here you can clearly see this is sorted. Here for the empty array they have given empty, and the list 1 consists of the empty, this one empty list, and this consists of the list 2 consists of one element here. So here this is just the one element from the list 2. So I hope the question is clear. Let's discuss the approach first as usual, then let's discuss the edge cases, then let's write the code and discuss the complexity of the code that we have written. Initially, as usual, we will be discussing about the approach. Let's discuss the approach step by step. Let me come here. Let me give approach here. So we'll be making use of the iterative merge approach. So just keep in mind, we'll be making use of the iterative merge approach, right? So what will be the first step here? We have to create the dummy node as placeholder just to start the merge list. The first step here is we have to create a dummy node, right? This is important. We have to create the dummy node as a placeholder just to start the merged list, right? In the second step is, let's move on with the second step. Let's use the pointer, any pointer. Let's consider here, let's use the pointer current here to track the current node of the merged list. We have to track the current node of the merged list, right? So to track that one, we are making use of the pointer current to track the current node, right, of the merged list. So this will be the second step. And the third step is we have to compare the two nodes from the both the lists. We have list 1 and we have the list 2. We have to compare the nodes from both the list, right? Suppose here value of the L1, nothing but the list 1, is less than or equal to value of the list 2. Then we are linking current dot next to L1 and we'll be moving L1 forward, right? This is what we'll be doing. Then otherwise, if L1 is here, same thing, sorry. L1 value of the L1 is greater than or equal to value of the L2, then what we will do? We will link current dot next to L2 and we will move L2 forward, right? We'll be moving L2 forward. So this will be the third step. I hope this is clear till the third step. Next, fourth step is we have to continue this process until one of the lists is exhausted. So continue until one of the lists is exhausted. One of the list is exhausted, right? So this will be the fourth step. We have to link the remaining nodes as well, right? If any of the nodes is still present, then we have to link the remaining nodes from the non-existed list to the merged list. Link remaining nodes, if any. We can just give here remaining nodes here. Final step is return the merge list, that is starting from return. We have to return the merge list, that is starting from the dummy.next here. This is very important. We have to return the merge list, that is starting from the dummy.next here. I hope this is clear. So I'll just explain one more time. So we are going with the iterative merge, this one approach. The first step is we are creating a dummy node as a placeholder to start the merge list. The second step is here we are making use of the pointer, nothing but in our case we are making use of the current pointer to track the current node of the merge list. After that one, we have to compare both the list, I mean nodes in both the lists, right? We have condition here. Just keep this condition in mind while we write the code. This will be very handy. If L1 value of the L1 less than or equal to value of the L2, then current dot next, this one, then current link the current dot next to L1 and move the L1 forward. Otherwise what we will do, we will if value of the L1 is greater than or equal to value of the L2, then we'll be linking the current dot next to L2 and we'll be moving the L2 forward. So we will be continuing until one of the list is exhausted, and then link the remaining nodes if any, right? If it's present, then finally we will be returning the merge list, that is starting from the dummy.next. So I hope this I hope the approach is completely clear. Then let's discuss the edge cases one by one next, and finally followed by the this one. Let's write the code, right? Let's go with the first edge case. Nothing but here, when both the lists are empty. Suppose if I consider here list 1 and list 2, they have given here, right? So list 1, let me consider this one empty. List 2 is also empty. Then the output should be here empty as well, right? So this is for the condition both lists are empty. So this is the first edge case. And let's move on with the second edge case. I hope this is clear. When one list is empty, means suppose let's consider list 1 as empty and list 2, suppose let's consider here 0. The output has to be, after merging, it has to be 0, right? Here output. So this is for the condition. This one, what we say, one list is empty here. This is one of the edge case. And let's move on with the third edge case. Nothing but when the lists of unequal heights. Unequal heights in the sense we can consider in this way, right? Suppose let me consider here list 1. What shall I consider here? List of unequal heights. 1, 3, 5. Let me give here. List 2. Let me consider here 2, 4. We shouldn't have the same length, right? List of unequal heights. So here 1, 3, 5 I have given, here 2, 4 I have given. So the output has to be, while we sort this one, the output has to be in the sorted form, right? So 1, 2, 3, 4, 5 should be the output here. This is for the condition lists of unequal lengths. Sorry, did I say height? Sorry, this has to be list of unequal lengths. Why did I say heights? This is fine. Finally, the final one is, or the fourth edge case is lists with identical values. Identical values means same values, right? So suppose let me consider here list 1, 1, 1. List 2 also here 1, 1. The output has to be here 1, 1, 1, 1, right? So this is for lists with identical this one, values. So here you can clearly see what are all the edge case that we have discussed when both lists are empty, and the second edge case was for when one list is empty, and the third edge case we saw for the lists of unequal lengths, and the final edge case was for lists with identical values. I hope all the four edge cases are clear. Next, let's start writing the code. So as we had discussed in the approach, so let's create a dummy node to simplify the merging logic here. So I'll just give here, in this case, let's make use of the new list node. We are just creating a dummy node just to simplify the merging logic here. So this is the first step. Next, we are making use of the current points. Basically, we'll be making use of the current variable or the pointer that points to the current position in the merged list, right? So let me give here current equals dummy. Next thing is we have to traverse both lists, nothing but list 1 and list 2 until one of them is exhausted. So we have discussed this one in the this one approach, right? So let's continue here, L1, while of L1 and L2. If we know this one, right? Well, value of the L1 is less than or equal to value of the L2, then what we will do? We will link the current dot next to the smaller node, nothing but L1 in this case. We have already discussed this one in the approach. So this has to point to the L1, and we have to move L1 to the next node, or we have to move L1 forward, right? So L1, I'll just give here L1 dot next in this case. This is fine. L1 dot next. So let me give here else. What I'll do? Else if a value of the L1 is greater than or equal to value of the L2, then what we will do? We have to link the current dot next to the smaller node. In this case, it will be current dot next will point to L2. Same thing here. Let me copy. I would have copied the two lines here. This is fine. Copy this one, and we have to move L2 forward, or we have to move L2 to the next node, right? L2 here, this will be L2 dot next. This is fine. Finally, we have to move the current to the next position after this. So how can we write this one? Current, I'll just give here current dot next in my case. So after this, we have to attach the remaining part of the non-empty list, right? If any remaining nodes are present. So we have to attach the remaining part of the non-empty list. So I'll just come here. Let me consider here current dot next equals either L1. We have two lists, right? Either it can be L1 or L2. What we are doing here, we are just attaching the remaining part of the non-empty list. And the final step, we have to return the merged list, that is starting from the dummy dot next. This one we had discussed in the approach. So this is very important. We have to return the merged list starting from dummy dot next, right? This has to be dummy dot next here. So I hope this is clear. Let me format this one once. Let me hit the run button. So we are getting wrong answer, right? What we are getting here? Output 1, 2, 4 we are getting. 1, 2, 3, 4 we need to get here, right? So 1, 1, 2, 3, 4, 4 we need to get. Let's see what I have done wrong here. So here what mistake I have done here is in the line number 6, this has to be double ampersand, right? So this is one typo. Let me run this code again. So yeah, now you can clearly see the sample test cases are getting passed here. So let me hit the submit button now. So you can clearly see here all the test cases are getting passed, right? So the code works absolutely correct here. So let's quickly discuss the time complexity and the space complexity of the code that we had written here. So the approach that we went with here is iterative merge, that we know, and overall time complexity here would be big O of m plus n or n plus m. So here it can be either big O of n plus m or big O of m plus n. So here we know that n is nothing but the length of the list 1 and m is nothing but the length of the list 2, right? So here n is nothing but length of list 1 and m is nothing but length of list 2. So we are traversing both the lists exactly once. We are traversing both the lists exactly once. So the overall time complexity would be here big O of n plus m. So this is fine. What will be the overall space complexity here? The overall space complexity would be big O of 1 here. Why it is big O of 1 here? Because we are making use of the only constant extra space for the dummy node. This one, dummy node here, dummy node and the pointers L1 and L2 here. We are making use of the constant space for the dummy node and the pointers, right? So the overall space complexity would be a big O of 1. I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.